Hi gents. Welcome to this robust course about VRF systems. By the end of this video, you will have a rigid understanding of the VRF systems and how do they work. Always be reminded to press the subscribe button so you will not miss any video in the future. Let us have a look on the different sections we are going to cover through our video. First section is a general introduction to VRF systems. Then we are going to see how the VRF systems works. Then we will go through the different types of VRF systems. And last section is about the hybrid VRF systems and their working principle. Variable refrigerant flow VRF, also known as variable refrigerant volume VRV, is an HVAC technology invented by Daikin Industries in 1982. Here is a photo of the first VRV units. Variable refrigerant flow is a technology that circulates only the minimum amount of refrigerant needed during a single heating or cooling period. This mechanism introduced the opportunity for end users to individually control several air conditioning zones at one time. Here is a timeline graph showing the growth of VRF systems. So, in 1982 Daikin invented this technology. Later of 1980s other manufacturers entered this business and remarketed it as VRF, because VRV is a trademark of Daikin. This technology reached Europe by 1987 and USA markets by early 2000s. By 2007, VRF systems are installed in Japan on 50% of mid-size office buildings and 33% of large commercial buildings. A study on 2020 estimated that China accounts for 67% of world's VRF market. By today, there are more than 40 global manufacturers of VRF systems, on top comes Mitsubishi Electric and Daikin. A typical VRF system consists of an outdoor unit, several indoor units, refrigerant piping running from the outdoor to the indoors, using ref net joints, which are copper distributors and pipes, and communication wiring. Communication wiring comprises a two-wired cable chain from the outdoor to all indoors, creating an internal closed-loop network. This is an essential part of any VRF installation. As for the control, each indoor is controlled by its own wired control panel, while there are some possibilities for wireless remotes and centralized controllers, enabling controlling all indoors from one location. How does VRF HVAC work? The operation logic of the VRF is fully built-in inside the system and is proprietary for each VRF manufacturer. The system gets inputs from the user, example, desired comfort temperature, and from the surroundings, example, outside ambient temperature. According to that data, it implements its logic in order to get to the desired comfort conditions, utilizing optimal power consumptions. Let's see a typical example. At the beginning, the system is in standstill condition. This means everything is turned off. Once a user turns one of the indoors on by its local remote, the outdoor gets noted regarding it, and starts working. At this point, it will examine the outdoor temperature conditions, the operating indoor requirements such as operation mode and set point temperature, and will operate the compressor at the exact level required to comply with the indoor requirements. When another indoor unit is turned on, the outdoor recalculates the requirements from all the indoors and will increase the compressor's output according to the required level of demand. This process is constantly occurring with any change performed in the HVAC system. As described, this system is fully automatic and regulates its power consumption based on the demand arriving from the indoor units and outside prevailing conditions. The modern VRF technology uses an inverter-driven scroll compressor. Here is a short animation showing a cross-section of scroll compressors and their working principle. The inverter scroll compressors changes the speed to follow the variations in the total cooling heating load. The capacity control range can be as low as 6% to 100%. Let's see how the inverter scroll compressor works. It is good to know that the relation between the speed and capacity is almost linear on scroll compressors. That is, double the speed and the capacity is almost doubled. For periods of high cooling demand, the input frequency of the compressor is increased. For periods of lower cooling demand, a lower input frequency is supplied to the compressor. periods of normal cooling demand uses the standard 50 or 60 Hz frequencies. Maximum required cooling capacity is achieved using 90 Hz for scroll compressor speed. On the other hand, minimum required cooling capacity is achieved using 30 Hz for scroll compressor speed. To run the compressor at higher frequency than the power supply frequency 230 volts 50 Hz, it is necessary to supply higher voltage to the motor. For 90 Hz frequency we need to supply a higher voltage to the motor, and is calculated as follows. "415 volts is the supply voltage to the variable frequency drive at 50 Hz. This graph shows the relationship for scroll compressor voltage, capacity, and speeds between 30 and 90 Hz. 30 Hz is the minimum speed required for proper compressor lubrication, while 90 Hz is the maximum speed to prevent oil carryover. So, with the inverter technology, a large capacity compressor operating at variable speed replaces 3 small compressors in a standard solution. Following illustration shows the difference between a conventional HVAC compressor that runs at maximum operation load until the desired temperature is reached and turn off until cooling is required to reach the set temperature again. So, the compressor is continuously turned on and off. On the other hand, an inverter compressor will continue to run, but only use the required amount of energy to maintain the desired temperature. This variable speed operation is not only more efficient, but also maintains more precise temperatures. In addition, this continuous smooth operation of the compressor translates to fewer maintenance calls and a longer lifespan for the motor itself. There are 3 VRF system types. Cooling-only systems. Those systems can only cool. Heating is not available. Heat pump systems, also known as two-pipe VRF, allow heating or cooling in all indoor units, but not simultaneous heating and cooling. All the indoor units can either heat or cool, but not at the same time. Heat recovery systems, also known as three-pipe VRF, allow heating and cooling in all indoor terminal devices simultaneously. Those systems are the most sophisticated ones. Let us see how a VRF heat recovery system works. In this system, each outdoor air-cooled condenser is connected via 3 pipes to an indoor heat recovery unit. A high-pressure gas refrigerant line for heating, a high-pressure liquid refrigerant line for cooling, and a low-pressure gas suction line for return to the outdoor unit. Each indoor heat recovery unit works together with the indoor terminal units and respective thermostats in each zone to determine if they require heating or cooling. An indoor terminal unit in heating mode is supplied with high-pressure gas refrigerant from the heat recovery unit. The heating mode indoor terminal unit acts like a condenser, and the refrigerant exits as a high-pressure liquid and proceeds back to the heat recovery unit. The heat recovery unit combines high-pressure liquid exiting heating zones with high-pressure liquid from the outdoor condensing unit and directs it to any indoor terminal units that are in cooling. The cooling mode indoor terminal unit acts like an evaporator, and the refrigerant exits as low-pressure gas, returns to the heat recovery unit, and then proceeds to the outdoor condensing unit to begin the cycle again. Our last section is about hybrid VRF systems. Hybrid VRF is a unique 2-pipe heat recovery VRF system that replaces refrigerant with water between the hybrid branch circuit controller and the indoor units. At the center of the system is the hybrid branch controller HBC, which is connected to the outdoor heat recovery unit via traditional refrigerant piping. On your right hand is a simple illustration of this HBC unit. There are 3 main parts in the HBC. A are the heat exchangers. B are inverter-driven pumps. C are the valve blocks. The HBC acts as the brains to the system. The outdoor unit delivers a mixture of liquid and hot gaseous refrigerant to it. This mixture passes through a plate heat exchanger to heat water by condensing the gas, and then the liquid refrigerant passes to a second plate heat exchanger to provide cooling. The key difference between a more traditional VRF and the newer hybrid VRF system is that in a hybrid VRF system, the need for leak detection is removed entirely as it uses water in place of refrigerant in the occupied spaces. Therefore, any risk to occupants and property under the EN 378 guidelines are removed. With F-gas regulations becoming more strict, there's also the benefit that the HVRF uses both 30% less refrigerant than a traditional VRF and is entirely R32 compliant. Let us list some of the main VRF advantages. In terms of comfort, the main advantage of a variable refrigerant flow system is its ability to respond individually to fluctuations in space load conditions. The user can set the ambient temperature of each room as per his requirements, and the system will automatically adjust the refrigerant flow to suit the requirement. From business point of view, VRF systems can generate separate billing that makes individualized billing easier. Design flexibility. A single condensing unit can be connected to a wide range of indoor units of varying capacity. Example 0.5 to 8 tons duct or ductless configurations such as ceiling recessed, wall-mounted, and floor console. Current products enable up to 48 indoor units to be supplied by a single condensing unit. In terms of energy efficiency, VRF systems use variable speed compressors inverter technology with 10 to 100% capacity range that provides unmatched flexibility for zoning to save energy. Field testing has indicated that this technology can reduce the energy consumption by as much as 30 to 40% a year compared to package or split systems. Here is graph showing the annual average efficiencies for each of the HVAC technologies for a study made in Dubai by the Regulatory and Supervisory Bureau for Electricity and Water. I hope you got valuable information. If so, don't leave before you press the subscribe button. Have a nice day.